How to check for outliers. So once you've got your quartiles, that's basically what you need, because if you look at these two formulas right here, it's the quartiles in the interquartile range, which is made of quartiles. So that's once you get there, you can do this. Essentially, the idea here is with these two limits, this lower limit and upper limit, they stretch way out. So that lower limit is going to be way below the first quartile. The upper limit's going to end up way above the third quartile. And they basically function as like fences or boundaries, where anything beyond those fences or boundaries would be an outlier if there's anything out there. Because you don't have to have an outlier every time. You can certainly have a data set that doesn't have any outliers in it. This data set also shows up in part 1 of the notes, and we did have the median, the quartiles, interquartile range already found for this. So this is the one where it has the calculator screenshots, which will work okay because we have an even number of data points, so then the calculator will do it the right way. And once we have the quartiles in the interquartile range, the outlier check is not going to be too bad. So the outlier check, so the lower fence would be the first quartile minus 1.5 times the interquartile range, and we just have to substitute in. So we'd have 64 minus 1.5 times 8, and 1.5 times 8 is 12, so this is 64 minus 12, which is 52. So then anything less than 52 would be an outlier, but you don't have to have any data points that are less than 52. And here we don't, because they're written in order up there. The smallest one is 58. That's not less than 52. So what we've got here is that there are no low outliers, right? No outliers on the low end. And then we can check the upper fence. So the upper fence would be the third quartile plus 1.5 times the interquartile range. So that's going to be 72 plus 1.5 times 8. So that's 72 plus 12, which is 84. And then we do the same thing on the other end where we say, okay, anything beyond the 84, which now would be above it, would be an outlier. But once again, there's no guarantee that there's anything out there. And here there isn't, because the largest value is 79. 79 is not bigger than 84. So there are no high outliers either. So altogether, here there are no outliers. And there we go. This second example is also one where we'd found the median and the quartiles, the interquartile range already. It's in the first part of the chapter 3 notes. It's the one that has the Excel screenshot with it. And again, since that's already done, we can jump right to the outlier check. So then the lower fence, first quartile minus 1.5 times the interquartile range. All right, so that's going to be 53 minus 1.5 times 50, but 1.5 times 50 is 75. So this is 53 minus 75, which is negative 22. And this will sometimes happen on the lower end. You'll get a negative value for the fence when there aren't any negative numbers in the data set. That's fine, right? That just means that the interquartile range is wide enough that it's pushing that fence that far down. And that will happen every once in a while. In a way, it feels like it's wrong because you're getting a negative number, but it's okay. It's fine. That will happen with a big interquartile range. So we don't have anything less than negative 22, that's for sure. The smallest number that's there is 0. So we have no low outliers. And then on the upper end, I don't think there's a lot of suspense here with what's going to happen. That 664 is pretty big. So third quartile plus 1.5 times the interquartile range. And that'll be 103 plus 1.5 times 50. So that's 103 plus 75, which will be 178. And yeah, we got something bigger than that. Right? The 175 barely gets in under the wire, but then that 664 is much, much bigger. So we do have an outlier. So 664. because that's certainly beyond the 178. So 664 is an outlier, and I guess just as a final answer for the outliers, it's just 664. Constructing box plots. We did talk about this a little bit, but it's worth running through it again. Essentially, the idea is that once you have the 5-number summary, which is your median, your quartiles, your max and min, and you've done the outlier check, this is the next logical step. So this is how you make the graphical display. Essentially what happens is you do the box first, which is determined by the 2 quartiles. So if you look at the one that's in the picture, which I can scroll down a little bit to get the whole thing up there, the box that's there, the bottom of the box is the first quartile, the top of the box is the third. The line that's in it is the median. So just from the way that the quartiles are determined, the median has to be between them, but it doesn't have to be halfway between them. That'll happen once in a while if you have a symmetric data set, that you might end up with the median right in the middle of the box. But it doesn't have to be there. It can be way over to one side, way over to the other side, and that's happening here, right? Like it's way down toward the bottom. That's okay, right? If you have a heavily skewed data set, which is certainly what this one looks like, then that kind of thing just happens. Then beyond that, how do you make the whiskers? This is more elaborate if you have outliers. If you don't have outliers, it just goes to the max and min, or they just go to the max and min. But really, the correct definition is that the whiskers are supposed to go to the largest and smallest values that are not outliers. So that does get a little more sophisticated if you've got an outlier or two. But then the best thing is to kind of draw the outliers in early and sort of work it from there. So if you look up here, these are all outliers. So these are the sorts of characters that software tends to use, like either this open circle where it kind of looks like an O for outlier, or maybe stars or asterisks and things like that. But that's what these are. So this data set has a whole bunch of outliers. It looks like it has 8, right? 3 open circles, you got 4 stars there, you got 1 way up there. But that's how it works. So box to get, or the box comes from the quartiles, then the median's aligned in the box. Then if there were outliers, I'd probably put those in next and then do the whiskers. Something like that. This one I don't think will be too difficult because we know there aren't any outliers, right? And we know that the median is 68. The first quartile is 64. The third quartile is 72. And then the max and min, when the data set's written in order, they're kind of obvious, right? The 58 and the 79. And we know there weren't any outliers, so the whiskers just go to the 58 and the 79. So I guess we can put them in here too. So min 58, max 79. All right, 64 would be a little bit below the 65. And 72, between 70 and 75, a little closer to 70. So maybe something like that. And then you just connect these lines together to get that box shape. All right, so something like this. And then the median is 68, so between 65 and 70, but a little closer to 70, something like that. And then we just have to go down to 58. And then up to 79. And that's it. So, no outliers. The box plot drops out pretty quick. This one is a little more elaborate because we did have an outlier. So we'd figured out what the median and the quartiles were. The max and min, right, everything's in order. Those are easy to catch. But the 664 was an outlier, which means that that upper whisker is not going there. It's actually going to the 175 because the 175 is the largest value that is not an outlier. So that's where that whisker is going to go. All right, so 53 and 103. This thing is really tall. I may have to zoom out a little. So, okay, 53 and 103. So 103, I guess, would just be like a hair above the 100. 53, I guess, aim for the middle between the 0 and the 100, maybe slightly closer to the 100. And then we can make the box shape. And then the median was 90. So that's going to be like way up here, right? So this one definitely not right in the middle of the box, but like we said, that's fine. No low outlier, and the lowest value is 0, so that's an easy one to get down to, right? It has its own hash mark. And then we said you don't go to 664. So 664 is going to be up here as an outlier. So I'm going to do the O for outlier up there for 664. And then we really only have to go up to 175, which ought to make the drawing easier at the very least. So something like that. And that's what the box plot here should look like. So on that higher end, you just have to go up to the largest non-outlier. And since there is one, we're not going to 664. We're just going up to 175. The next section is about how to compare groups. And this first part is essentially saying you could do it with a histogram if you wanted to. It may be tougher to do side-by-side comparisons that way just because histograms are so big. But you could, right? If you look at these two histograms, you have one for 2002, one for 2003. And then you can see, well, those shapes, maybe they're a little bit different, right? It looks like the peak is a lot taller in the 2003 one on the right. It looks like there's a little bit of skewness there. It looks like it's left skewed. It's got a little more left tail over here than it does a right tail over there. And then maybe the one on the left for 2002 is just like, it looks a little more symmetric, right? I mean, you could say maybe it's a little bit right skewed, but it looks more of just like a hump, like a kind of symmetric hump, certainly a lot more than the one on the right. So sure, you can do comparisons this way, but the more conventional thing to do is probably to use box plots because they're smaller, so you can do more comparisons and you can stick them all into one graph, like this. So for side-by-side comparisons, look how many years are getting stuffed into this, right? It looks like, oh yeah, we got 8 years in there, no problem. So that's where the box plots can actually be really handy. And then if there is a big difference, all of a sudden, you're going to catch it. Because look at this, right? Things are at least kind of consistent for a while, and then we get to 2008, where you have a ton of variability, right? Like the box is gigantic. So the interquartile range is enormous, right? Like that's why the box is huge. And so a ton of variability, like a lot lower, and then 2009 is just flat, right? It's down at 0. So that's AIG's stock price, and what happened in 2008, right? That was the collapse of the housing market, right? So a company like AIG, that was going to be the effect. So 2008 was basically, while it was happening, there was the big drop, right? So like the later half of that year, that's when things were really dropping off. So that's why you get that huge range for 2008. Because it wasn't like, it wasn't like the collapse happened on January 1st, 2008. It was like sort of getting into the second half of the year. So, right, it's got to fall off from where it was in the beginning of the year, and you get that enormous range of values. And so, yeah, that would be why that box is gigantic. And also in this picture, you can see some outliers. I should point that out too. Got a couple in 2003. Looks like there are 4 of them in 2004. It's hard to tell how many there are here in 2007 because it looks like there are a couple on top of each other, like on the top of that stack. But look, there are a few there anyway. The last big thing in this chapter is the idea of a time series plot, which is when you graph the value of a variable over time. So you make the same measurement over and over and over again. Maybe it's every day, maybe it's every month. Maybe it's every year if it's a really long-range thing. And then you'd have time on the x-axis and then whatever your variable is on the y-axis. And then that way you can see trends. Like, is it decreasing over time? Is it increasing? Did something happen where it went up and then went down? Those sorts of things. So we got 2 graphs in here. One is a histogram. So, okay, we can make that, right? We had that histogram already. It's at the beginning of the chapter 3 notes. So that's the AIG stock price in 2008. And say, okay, I see that. I see where the peak is, right? So one peak, unimodal, and then left skewed because there's more over here than there is over here, right? Longer left tail than the right tail. Okay, sure, we've talked about that. But then if it's something where you'd anticipate that maybe the variable would change over time, you probably want to display that, right? You probably want to be able to see that visually. And that's where the time series plot comes in. And that's what this one down here with the maroon dots is. Because then if you look at the x-axis, you have January '08, February '08, March, April, May, right? And so there is a decrease, but in through here, it's not too severe, right? And then it gets a lot steeper and then just drops. So we can see all that in the time series plot, but you can't really see it in the histogram at all, right? You can't see that trend over time. So I think the best way to say it is, if you think that there might be some kind of trend over time, then just graph it and find out, right? Just make that time series plot, right? I mean, it's not like it takes that long to make one of these graphs, not anymore, right? Like you just have software do it. So I think that's the best way to say it. Just if you have a variable where you have an inkling or a thought that maybe there's variation over time, then maybe make the time series plot in addition to the histogram, right? There's nothing wrong with having an extra graph in there. The summary part at the end. Let's see. So just to try to hit some of the big points. So histograms are for quantitative variables, not categorical ones. Bar graphs, which look awfully similar, are for categorical variables. Then some of the stuff down here. Let's see. So shape, center, and spread. There was an awful lot of that in this chapter. So shape, the biggest thing is being able to tell apart left and right skewed. Right? To tell apart symmetric from a skewed shape is really not that difficult. But left skewed and right skewed, it's easy to get those backwards. Then unimodal versus bimodal, right? Those tend to come up, right? It's how many peaks do you have? Unimodal's 1, bimodal's 2. Multimodal would be more than 2. Let's see. Computing the mean and the median. I think it would be a good idea to know how to get the median by hand, at least for a tiny data set. They might show up that way on the test. So, right, put everything in order, and then odd number of data points is the one right in the middle. Even number of data points, you're going to average the two in the middle. The mean is just the average, right? So that one isn't going to be anything too crazy. Let's see. Standard deviation, I would never ask you to compute it manually from scratch. I think that's kind of what the calculator is for, to do things like the standard deviation. The interquartile range on a test, I think you do have to know how to do it manually, because with an odd number of data points, the calculator doesn't do the quartiles the right way, like the way that the homework does it, so it kind of ends up inconsistent. So, I mean, again, it would just be for a little data set on a test if there's one where you have to get the quartiles, the interquartile range. Z-scores, we basically just use those to compare a value from one distribution with a value from another. So that's, at this point, how those are going to show up. They do have other applications later, but those will happen later. Let's see. Then making the box plot, that was this one. So do the outlier check, right? You got to know how to do that, because then if there are outliers, that's going to affect what the box plot looks like, right? It's going to affect where the whiskers go. And then using box plots to compare distributions, that was that graph that had the 8 box plots on it. So for comparisons, the box plots look really well because you can kind of shove a whole bunch of them into one graph. And then a time series, if you think that there might be change over time, just have the software make one and check, right? Just to see if there are any trends there. And I think that will do it for the Chapter 3 notes.